Today we're going to look at lesson 9.3, which is solving quadratic equations. So we are going to solve quadratic equations by graphing today. It says the x-intercepts of the graph y equals ax squared plus bx plus c are the solutions of the related equation ax squared plus bx plus c equals 0. So remember, x-intercepts are where the parabola touches the x-axis. Just like we've been identifying the y-intercepts, the ordered pair where the parabola touches the y-axis, here x-intercepts are where the parabola touches the x-axis. Okay, so when asked to find the solution of an equation or of a quadratic equation or the roots of the equation, those two things are interchangeable. It's the same thing as finding the x-intercepts. So all of those words mean the same thing. What we want to do is figure out where does the parabola touch the x-axis. Okay, so if we look at these several pictures here, we're going to use the graph that's already provided to us to solve the equation. Okay, so if we look at the picture in part A, once again, to solve means that we're going to find the solution or find the roots. So basically, we need to look for x-intercepts. So that means I need to look at the x-axis here, and I'm trying to determine how many times does the parabola touch it. Notice that it touches it, in this case, not once, but actually twice. So that means that we are going to have two solutions. What we're going to do is we are going to write those as ordered pairs. So notice that the first place that it touches it hits at 2. So that's why if it's an x-intercept, you'd put that number first, but then because we didn't move up or down, 0 would go second. So we have the ordered pair 2, 0. But because there's 2, that means we'll have 2 ordered pairs. If I look at the next number, it looks like it's touching at 8. So we would say we've got the ordered pair 8, 0. So 2 spots, 2 solutions, 2 ordered pairs. If we look at the picture in B, notice how once again we need to focus on the solutions, which means how many times does the parabola touch the x-axis? Notice that in this picture, it touches it once. So that means that we will only have one ordered pair to write for a solution. Notice that this happens to hit at the origin, which is the ordered pair 0, 0. So that's my one and only solution. If I look at the picture in part C, once again, to determine my solutions, I'm looking for how many times does the parabola touch the x-axis. Notice that in this case, it doesn't touch it at all. And so when it doesn't touch it at all, we would say that we have no real solution. All right, so those are our 3 options. Your parabola could touch the graph on the x-axis at 2 spots. It could touch the x-axis at 1 spot, or it could touch it never, making it no real solution. So a lot of the times you won't just have a picture to identify your solutions. Sometimes you're going to have to first create your picture, and then you can determine your solutions. So it says, let's find the solutions to the equation by graphing x squared minus 1 equals 0. Okay, so they gave it to us as an equation, but notice that when we are actually going to create our table, we take it and we can really think of it as y equals x squared minus 1 because we want to come up with ordered pairs for x and for y. But notice that the reason why they gave you the equation that it equals 0 is because if you look, notice that every y value, if it is a solution, it touches at 0 for the y because that's what happens when you have an x-intercept. Okay, y is 0. All right, so remember our steps in order to graph. We want to first identify A, B, and C. So A, B, and C. Notice that my a value is going to be connected to the x squared. Well, there's no number in front of x squared, so it's 1. Remember, b is what's connected to x. Because I don't see an x term, that means that b is 0. The c value is the constant. Don't lose the sign. It is -1. So then remember, we want to figure out the axis of symmetry by doing x equals -b over 2 times a. Because we have a -0, that's really just 0 on the top. 2 times 1 is 2. So x equals 0 would be that axis of symmetry. So that means that 0 would go in the middle of our table. We'll pick values to the left and to the right. So we're going to pick -1 and -2 as we move to the left. We'll pick +1 and +2 as we move to the right. So remember, those are the x values of my ordered pairs. And now we're going to start plugging in those numbers. Because there's only one x in this particular problem, we'll only have one spot to plug in our numbers. So we'll have -2 quantity squared minus 1. So you can use your calculator, or -2 squared would be +4. 4 minus 1 gives us 3. So I'm going to plot -2, so 2 to the left, and 3 means we go up 3. Now I'm going to plug in -1. So we'll have -1 quantity squared minus 1. Well, -1 squared is +1. Minus 1 is going to give us 0. So -1 means we move to the left. 0 means we do not move up or down. So there's my second point. When I plug in 0, we'll have 0 quantity squared minus 1. So we'll have then 0 minus 1. So -1. 0, -1 means we don't move left or right, but we do move down 1. When I plug in +1, we'll have 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. So move 1 to the right and then plot your point because we don't move up or down. Then we have y equals, we'll have 2 quantity squared minus 1. 2 squared is 4. 4 minus 1 will give us 3. So 2 to the right and 3 up. So notice that here is my parabola. Okay, if we wanted, we could draw in an axis of symmetry of x equals 0. So notice that technically our axis of symmetry is on the y-axis. But remember, this time, I'm just asking for solutions. So we could go ahead and we could identify the vertex, and if we have a min or a max, and what the y-intercept is. We could do all of those things. But this time, it's just asking what are the solutions. So remember, solutions are just where does it touch the x-axis. Notice that it's touching it at 2 different spots. And so we'll have 2 solutions here. So we're going to have the ordered pair -1, 0, and we'll have the ordered pair +1, 0. And that'd be our answer.